Okay, so let's take a look and have a major takeaway from the previous methods that we've tackled, no, concerning the integration of the um, what do we call this heterogeneous systems for an enterprise business. So we've talked about the file transfer and shared database. So both of these methods enable applications not to share their data, but not their functionality. So always remember that. With file transfer, it allows you to keep the application very well decoupled, but at the cost, no, of the timeliness, because it costs you a lot, no, when you transfer data from one destination to another. And then we also have this shared database. It keeps data together in a responsive way somehow, but at the cost of coupling everything to the database. And we we ano kanang we consider its schema. So everything is really decoupled on the database, especially during the development. You 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 tend to fall on the schema alone. It also fails not to handle collaborative behavior. So we can share for a shared database method alone, no, implementing on enterprise business. So it fails not to handle collaborative behavior because you only share the data, though even though you share it very wisely and very precisely and efficiently. And then we've also talked about remote procedure invocation, which enables application to share functionality, but tightly couples them in a process. So we've already considered this idea before. Once mo share ka no via mo share ka og resource via remote procedure invocation, whether you use the method of HTTP, using application programming interface, or even sharing object using remote method invocation and DCOM or Corba. uh, Whenever two applications are running and that applications are communicating, no, at the same time, and they are running at the same time, so they are actually highly dependent on each other because you share resource which runs on different platforms, no. So an application that communicates to a particular applications which that application is highly dependent on. So whenever that particular applications that the other applications are communicating, so once say for instance the server is down or unable to hand over a particular resource, so that would be a major problem for a particular application wanted, no, a particular resource during the movement process. So it tightly couples both applications during the process. So even though remote procedure calls looks like local calls, even though a resource looks like a local resource during the process, they don't act the same. Remote calls are slower and can fail. With multiple applications communicating across an enterprise, you don't want one application's failure to bring down all the other applications. So that's a major takeaway, you know, for an enterprise business. And you don't want to design a system assuming that the calls are fast. You don't want each application knowing details of other applications, even if it's only details about their interfaces. So we've mentioned that why during the quiz now we mentioned why do we have to interface other applications, no, towards other applications, because those applications that are interfaced together are different. So that's also a major takeaway. No, we often assume that a particular process is fast, but in reality, it costs a lot. No, in terms of its efficiency. So with these methods mentioned, or with these methods in mind, there's a lot of challenges or difficulties along the way when implementing about these methods. So the book that that I gave you is the focus, or the ultimate method that has been used on the or shared on that book is about messaging. So you'll assume you'll assume that you will acquire knowledge, and techniques on how to deal with messages along with the for an enterprise business. So please take note that often the challenges of integration is about making collaboration between separate systems as timely as possible. So without coupling systems together in such a way that makes them unreliable. So we don't want to make both applications be dependent on each other. So either in terms of application execution or application development. So um, the way we deal with the way we adopt integration for an enterprise business, having multiple systems, is we implement methods. So we look forward on especially during on the development or even the application execution. So that's the kung ano kana mo na gina ato ang hatagan og much consideration once we adopt particular method for integration. So um how about messaging? So this is another method for integration, no? So what it does is that it allows interactions, no, between applications possible. Still, it is similar to the approach of remote method verification. Um, think of it as similar, no, similar technique or functionality or features offered by remote procedure call. So it allows interactions for both applications or between applications, no, possible. So, one of the capabilities and features of a messaging. But as to the message, no, we message passing, no, can be used to transfer of data frequently, immediately, reliably, and synchronously or synchronously using customizable formats. So we have a freedom to put up a series or couple of formats for our message to be thus our message becomes more customizable concern in relation to asynchronous or even synchronous, no, processes of multiple systems. So for asynchronous message is asynchronous messaging is fundamentally a practical solution to the problems or of distributed systems. So let's see why. There are major advantages for a messaging method. First, sending a message does not require both systems to be up and ready at the same time. I've already gave you a short or a quick overview of what it looks like when a systems performs multiple systems performs messaging asynchronously. Similarly, decoupled when messaging similarly decoupled when using file transfer. It is similar with the idea of file transfer. So messages can be transformed in a transit without either the sender or receiver knowing about the transformation. So this is also an advantage because especially when we're dealing with development, we don't necessarily update or make a major update to a particular system. All we have to do is to make quick changes or update on the broker itself, no, or on the transforming systems or transforming mechanism put up on a middle layer, no, of the systems process. It also allows integrators to broadcast messages to multiple receivers, support choosing one of the many potential receiver and other topologies that allow integrations to be separated from the development of the applications. So we can also perform, especially with messages. No, we can perform broadcast messaging. So the advantage of broadcast messaging is whenever there is an update to a particular service provider or server providing service, so we can inform all other subsystems via broadcast message. So they are obliged not to update their UIs whenever there is a changes. Whenever there is a broadcast message accepted from particular client. So those clients' UI are obliged not to update their UIs when broadcast message arrive to them. So ang responsible, no, to make a broadcast, to perform broadcast is katong service provider, katong server. No. By sending small messages frequently, you also allow applications not to collaborate behaviorally as well as share data. So this is a sort of a combination of file transfer and remote procedure call. Dili siya atong shared database, which often leads to multiple applications that are highly dependent on a single resource or a single unit. So yeah, for its difficulty, applications no can still have quite different conceptual models. So this is really hard to deal with during the development process. So meaning the result would be the semantic dissonance, no, for both applications. So for the data, no, that they share, they both consume. So collaborations aren't fast compared to remote procedure invocation because a message would travel could travel for about no, for one to two or three brokers. So you can design your architecture that way. Um, Unlike remote procedure call, which the response is dedicated to a single unit alone, a single system. So there is no message broker or a broker, um, the broker in place. So asynchronous design is not a way, most software peoples are taught. So most of the developers are um, not so in favor of the idea of asynchronous process because the requirement uh, has to put up a broker, has to put up a middleware, which tends to make developers strive really hard, no, for putting up a lot of effort, so sticking up a lot of codes to the integrated systems, and this would result, no, that there's a whole host of different rules and techniques in place. Also, testing and debugging are harder in this environment because you'll have to wait, no, for another application to respond, and the response could arrive first on the broker before system, no, before a particular system asking for that response, no, uh, responded to a particular user interaction. So dugay ang iyahang ano, dugay ang iyahang result magawas kay there could be tons of there could be tons of domains in place during the entire process. Because we're talking about the greater systems in place, no. So uh, I believe that there are a lot of questions coming in mind no, when during when you hear, no, or when you watch this video. So let me help you that by answering some of the common questions related to messaging method. Once you decide that you want to use messaging for system integration, so there are a number of new issues to consider and practices you can employ. How do you transfer packets of data? So that's one question for for a method of messaging for system integration. We can answer that by simply saying that the sender sends data to a receiver by sending a message via message channel. So you should incorporate the message channel, no, along with the communications of two or multiple systems. So message channel will connect, no, the sender and the receiver. So that's how simple as it may sound, but uh, given mag put up ka og message channel isn't really ano, as simple. So how do you know where to send the data? So we will talk more about message channel, no, on the succeeding slides. But take note of a message channel. The idea of a message channel. Take note of the message channel, no, which is one requirement, not just a broker or anything, but we'll consider message channel as part of the component of two systems communicating when using messaging for system integration. How do you know where to send the data? So if the sender does not know where to address the data to, no, it can send the data to a message router, which will redirect the data, which will redirect the data to a proper receiver. So there might be multiple systems, no, connected to a particular message channel. So in order for your data to really brought up, to really hand over to a particular or to attend uh, to an intended receiver. So we can put up we can put kung ano kanang via message format. We can indicate our particular receiver to in the message. So thus the message router knows asa gid siya dapat siya i-hand over, no. So mo na yung responsibility for a message router. This will redirect the data to a proper receiver. So first we have a message channel, and then the message channel connects sender receiver and also a message router, no, that redirects a message to a rightful receiver. How do you know what data format to use? So if the sender and receiver do not agree on the data format, the sender can redirect data to a message translator and will convert the data to a receiver's format and then format the data to the receiver. So another advantage, no, of messaging services, or I mean, a messaging method for your integration, integrating for your system integration is that we can dynamically uh, set our message of how a system integration of what the system integration scope. Say for instance, there are a lot of systems in place, and they wanted a particular they wanted they wanted different formats for their application to consume. So put you can add up a message translator which dynamically handles, no, different message formats. So, yung flexible and dynamic ang architecture ng implementing messaging method. If you're an application developer, how do you connect your applications to a messaging system? So, an applications to use or wishes to use messaging will implement a message endpoint to perform the actual sending and receiving. Still, gamit gyapon tag mga HTTP ani, no, in order to implement endpoints. So asa man ang endpoint sa imong application when you send data from one application to another. So basically you use kung ano kanang HTTP, you indicate sa imong application as ang destination first, the protocol, the domain, and then iyahada yung kung ano, iyahada yung address. So, mo na imong message, mo na imong endpoint. So, dito na mo na indicate during the sending. Indicate nimo asa padulong ang imong message. Naman na sa imong naman na sa both ends of the application. So first, message channel, message router, message translator, message endpoint. So these are the domains we should consider, no, upon using messaging for system integration. So don't forget that. The what do we call this? The bigger, no, the biggest idea of messaging or implementing a messaging, no, for system integration is that there has to be a message broker, no, in place. So a message broker provides message queue, no, to provide persistent mechanism. So uh, looking back on the fundamental challenges of integration, we have a network, no, that are slow and unreliable. So how do we deal with it? So first, we must have a broker in place to really monitor if the network will have come back or restored, no, restored to its present condition. If the network is capable of sending the message, no, to the actual endpoint. So siya ang mag-monitor, siya ang responsible. So that what makes a message broker becomes persistent during the process. So iya yung pugson nga ang usa ka message no, with a message payload na ay mga instructions ana yung i-push padulong dito sa uh, expected receiver. And then another advantage is that iha ng EQ. So wala dili magka kuano dili magkayagaw ang imuhang mga messages along the process. So unsa to'y pinakauna mo dito ang i-serve first. The first in first out, no, na mechanism. So for a message queue, no, this is placed, no, between two parts of the system in order for them to communicate with each other. So producers can create messages and deliver them to the message queue. So dinhi um o nakay client, then nakay server. So nakay broker yun, no. Nakay broker in place, no, and is responsible no, of two applications communicating. So before a message mo arrive directly padulong this server, it has to be queued diha as a broker na part na section. So mo man na iyahang responsibility. Okay? So yeah, um so producers can message and deliver message to the message queue. So even the producers, no. So this is back and forth, no, back and forth process. So if the server wanted to push on a response, it does so by uh, giving it to the broker first, and then the broker will hand over the response to the expected client. So yan, naka-busy ang broker na. So consumers can connect message queue and subscribe to a message from the queue. So na publish subscribe mechanism. Messages placed on the queue are stored until the consumer acknowledge them. So begin mo monitor at the same time the message queue or the message broker acknowledgement of of the data that has been passed on. Another thing for message broker, aside from having its queue system, so it facilitates asynchronous communications between applications. Of course, no, na i-queue man nimo, and then persistency, so capable of performing asynchronous operation ang imuhang integrated systems. It minimizes the mutual awareness between the microservices. So, of course, pag once imuhang i-share no, ang imuhang resource or data from one computer to another, one applications to another, so you don't want no to make a message contains tons of instructions or data or having a bigger payload. So kinahanglan nimo na you'll treat it as a microservice no. Gamay lang gid siya, gamay lang gid siya sulod ni instruction no. So dili nimo i butang tanan nga instructions sa usa ka message. You will treat as a microservice. So the way you share it as a microservice. Mga ingana nimo pag-treat ang imong messages, and it prevents no, it minimize rather no, it minimizes no the mutual awareness between the microservices. So dili necessary makabalo si server asa gigikan ang service, or even si client di siya makabalo asa gikan ang data. So it really decouples and detaches the sender from the receiver of a message. So um, meaning dili na required ni client makabalo kung unsa asa gikan ang data, unsay specific format. Ang broker na bahala na. Okay? It creates a system that is easy to maintain and scale. So, kung imo ning kung ano, kung tan-aw ni sa mga developers, no, tan-aw nila ni as an architecture, they can easily put up uh, uh, they can easily scale no, scale down or easily maintain no. Kay dali ra man ma-scale ang system. Dali ra man makita no asay part nga need no, need og upgrade, need og maintenance. So dili naman ka ma-worry nga once nakahilabtan sa server affected ang client. Kay ang effort, more of the effort during the development would happen in the broker no. It all allows no for different parts of an applications to evolve independently and be written in different language. So we don't really worry on say you developers will have freedoms no, or free wheels of choosing different programming language based on their expertise. So dili na ta kinahanglan o worry about a certain expertise of the developers when employing them to a business to develop that systems. Yeah, so pwede mag-evolve, say for instance na kay another systems niya the client 2, so kung i-upgrade nimo ang system 2, so dili necessary affected no, it won't matter no kay dili man affected si client 1 ganyan ana. So we have this Java message queue no, aside from RabbitMQ and Kafka or Redis. Since Java man itong nasugdan, we've used Java for a demonstration of Java message or Java remote method invocation. So since we use Java, so magpadayon tag use of Java. Okay, simple raman ang Java no. On a particular sense, simple run Java. So let's take a look on a message Java message queue. This can be compared on RabbitMQ, Kafka. So for Java message queue, this is a messaging service that is used to create, send message, receive message from one applications to another. So it provides reliable, highly scalable, loosely coupled, and asynchronous communications from microservices, distributed systems, and serverless applications. So, nakay duha ka senaryo ani karon. So you can implement Java message queue even to a point to point no nga scenario. So you'll have message queue, you can pass or broadcast a message, list of consumers one at a time. Also have publish subscribe na mechanism. So say si publisher or si server can broadcast a particular message queue or a particular message on the queue. No? Say for instance, the three message could really pop up on different consumers, no, multiple consumers at the same time. So nahingan ano to publish subscribe na mechanism. So this can be happen implementing input output no katong socket IO. So pwede nimo i-publish no mo occur ang message at the same time sa, sa multiple consumers. So yeah, the publisher should publish to the message broker and the consumer should subscribe to the GMS broker. Kung nag-JavaScript ka ani, mag-implement kag listen nga function nga mo listen kung na i-broadcast ng message uh, every time no from moment to from on sa mana real time. So processes running on a different host on the same network or loosely connected through the internet can connect to the service to interact with each other. Others all offers all the features required by large-scale enterprise development. So, yan ang powerful si Java Message Queue. Also, may mga core components there ay sa JMQ. So, there are eight no, considered here no, for as a core component make up a Java Message Queue application. No, first is NAI provider. So, a provider also known as a message-oriented middleware. So, it is an interface for sending messages. It prescribes the object sent and the object involves in the conversation. It also provides control and admin features. So think of this GMQ as kung ano mura po siya RMI nga model wherein na kay registry. So aside from the features of aside from the features of the GMQ similar to RMI is that it offers kung ano a message-oriented middleware meaning ma-queue niya, no, mahimong persistent na model, no, persistent ang mechanism wherein na kay message, it could really oblige no that are that the particular message JMQ would persistently push a message or broadcast a message to the kuan to the receivers. So aside from the kuan no kanang provider, we also have the client. So a client is a Java application that is either producing or receiving messages. So yeah, we also have consumer or subscriber. I mean producer or publisher. So producer is a client or system that creates and send message. So client no pwede po siya kung ano mo produce or mo receive og message. So yeah, yan naman ang simple architectures for a kung ano client server nga scenario. But we're not only talking about a simple client server mechanism, but we're taking care of much more bigger systems no on the way. So we also had consumer subscriber, no consumer is a client that receive messages. Even si server no can be a consumer. It can subscribe or publish at the same time. We also have message. A message can be anything you like, but usually it's text or bytes organized in some agreed formats. So later no, in the final, we'll be dealing with messages, how to kuan kanang extract or parse a particular message. You can think of a message as an XML. No? We can wrap an XML into a message and send. No? Send it out, padulong dito sa broker, and then si broker natay i-put in place no, a mechanism where we could extract or retransform a particular message to another format. We also have message, no, a message. Oh no, we also have the destination. In between the producers and the consumer is a queue that facilitates the communications. This is what is referred to as the destination. All of the destination, no, all of the message, no, or data destination would be kanang si JMQ, kanang si message broker. So queue, no, if your message needs to be received by only one consumer, so you need to use a queue. A queue guarantees delivery to one and only one client. If more than one consumer is connected to the queue, so only one consumer gets the message. It's first come, first serve. So we also have a top pick. If your message needs to be received by any and all consumers listening, so you need to use a top pick. Topic is a special type of queue that guarantees delivery to all consumers subscribed to the topic. So dili lang queue ang atong ina-deal ani when we talk about bigger systems, so topic na gid guys that be consumed by multiple applications. Yeah, ang iyang models are of two types, no? That is supported by the Java message queue. We have this point-to-point message domain. We have a publish subscriber message domain. So for PTP, no, message or P2P or PTP messaging model, so one message is delivered to one receiver only. So the model is built around the concept of queue, which is used as a message-oriented middleware. So messages are stored in the queue by the producer's applications, and the consumer receive the message from the queue. So this facilitates the storage and forwarding of the messages to consumer applications in a synchronous decoupled manner. So for this reason, guys, I guess di na lang po makata sa inyo yung project. Um, yeah, kay given sa time, no? Magtuon sa tatong parsing, no, of message. Maybe sa kuan na lang sa final na lang nagtibo na lang nako ang inyong project. So in the PTP model, the message is delivered to the receiver only once. Once received and acknowledged by the consumer, it will then be removed from the queue. Nga nakasimple ang iyahang model. For a pub-sub no messaging model, so in the publisher subscriber pattern, so you have the sender, the receiver, and the receiver, and the multiple queues called topics. Still, ang element of the topic are still called messages. So the publisher, but ang idea lang ani it is that both messages can be received at the same time, no, for different applications or different systems. Well, in this case, we have the system B and system C. So the publisher can send one message and it will deliver to all the subscribers of the topic, just like broadcasting. Here, the topic is used as a message-oriented middleware that is responsible for storing and delivering messages. So the message will be removed from the queue only when all the subscribers have successfully read the message or when the retention policy expires. Have you encountered? I believe you've encountered no a particular um, client scenario where whenever you wanted an update sa imuhang end, kinahanglan pa nimo i-refresh ang imong browser. So we often encounter the particular kung ano scenario man on our daily life. Kabantay mo pag na-pour kayo nga system, dito na nimo makita ang changes once i-refresh nimo. So poor kay siya nga mechanism. Um, ayo siya given nga kuan considering nga kusog na kayo ang network, kusog na kayo ang internet ana, kinahanglan pa nimo gihapon i-reload, no, ang browser to see the updates. Pag once na kay subscribe mechanism, ang imuhang gigamit anang application or you're using the application in the client end. So naay kuha na subscribe mechanism. If naa siya subscribe mechanism, so your end listen all the time to whatever changes or whatever messages, no, occur on the GMS topic. So pag naa mo automatic na lang nag-change mo without reloading your page. automatic na nag-pop up ang mga changes kabantay mo for instance sa Facebook. Na siya, I believe na siya ko ano, just like the Facebook no na siya murag kuan ba, let's assume nga subscribe mechanism ang iyang gamit ana, no? Whenever na imo like sa imong image, na imo like sa imong kuan na notifications, no? So mo pop up na dito sa bell icon na 1 na 2 or kung ano ba, as long as na mo pop up kung ano na inyo ang bantayan, no? My meaning na siya that can be likened to a subscribe mechanism. So yeah, next is, so what is Java Message Queue, no, used for? So the Java Message Queue can be used to develop distributed applications, no, that follow an asynchronous messaging design pattern. So it defines an event bus, no, that buffers the message between the sending and the receiving process. So na i-buffer ana, no, meaning na sa ka storage somewhere on the somewhere sa imuhang provider. So dito na i-pick up sa imuhang mga receiver. So i-buffer niya. So this allows for non-blocking I/O where the current process of the client operations are not blocked while waiting for the downstream consumer to process the message. So dili na niya i-remove, no, ang buffer. Mo ni trabaho sa event bus. It can be used as a message-oriented middleware that allows for transactions or event notification to be sent and received over distributed software applications that are spread across multiple operating systems and network protocols. So it can be used as a cache if required. It can be used as a cache if required. So kung nakay kung na pwede nimo add og mechanism nga pwede niya i-cache ng mga previous processes in order, so that it guarantees, no, particular message to really be broadcast, no, sa tanan ng mga applications connected or requiring the process. So when building, no, a distributed system, caching is often primarily considered for capacity planning. So it features allow the Java message queue to be used as a caching technology. Pwede niya i-remember sa itong mga messages nga ni-arrive even though successfully delivered sa other systems but not for some systems. So yan ang set aside, yan ang i-cache, yan ang i-save until once the connection will come back, no, for those applications nga mag-need atong ilahang i-consume. So ihatong i-process, no, later na yan. It provides well-defined rules for application-to-application messaging such as syntax, no, semantics, and load balancing, and failover. Yan ang powerful sa message queue. Um, or si Java Message Queue. It also provides standard mechanism for applications running in a Java environment to interact with the synchronous messaging systems. It also provides a client interface, no, for both PubSub and TTP messaging models. So which is why it really suits, no, for our demonstration if we have, no, in the future. JMQ advantage is that it is capable of high throughput, no? Since the Java message queue follows a synchronous messaging pattern, so you can expect better performance, no, because the clients that are producing consuming messages interact with the queue and not each other. So no client would stall because they aren't waiting for the completion of the message consuming or message consumption. So walay client na mo stop ang iyang process. Robust and reliable. So messaging using a Java message queue is reliable as it ensures, no, that a message is delivered to the intended consumer once and only once. So when the duplicates can't be tolerated, so there are mechanisms in place to filter out duplications. Fault tolerance, no, so Java message queue can mitigate the errors that occur when some of the components and applications are unreachable since the messages are persisted in the staging area. So therefore, when the components are recovered and get back online, the Java message queue can pick up from where it left, without affecting other components. Breakup apps, no, you can use it to decouple monolithic applications into small self-contained applications. So, kung may monolithic, so highly dependent to one another ng mga applications. For instance, na kay two applications, the applications A and B, where each of them are highly dependent on the database, and then PGI, um, let's say highly dependent for CF on the cloud services. So tipo, no, they are highly attached, no, to one another. So meaning applications A and applications B are really tied, no, to one another. Meaning kung ang B operations on the B fails, so si A pod will fail. Kaya ana ang usual scenario may tabo o sa monolithic nga mga applications. So, uh, yeah, ato siyang i-break, no? I-break na to, no? So, instead of execution or executing multiple functions within a single executable, so you can have many programs that each perform a discrete functions. Bulag-bulag na siya. Wala sila pakialamay sa usag-usa ng mga applications. Wala sila pakialam sa imong database, no? Sa imong database. So bulag-bulag unsay mohang API sa panggamit. So this makes the system easier to test, debug, evolve, and scale. Dali ra nimo ma-determine ang scope to a particular applications. Kay di man ka ma-worry if na kay update na ma-update ko ng other systems. So JMQ disadvantage is that somehow no na siya disadvantage. So this idea is not for the message but for the Java message queue. Not for the Java messaging mechanism but for the Java message queue. Problema lang similar with RMI, no, Java RMI is that it is a Java based, and this means that it can only be used to implement Java messaging systems in a Java compliant environmental applications only. It does not support other languages, no, in distributed inter applications that use multiple language, no, frameworks. So this can become an impediment. So Java message queue has no specific message format, which is a limitation. So better siguro sa inyong final we will use RabbitMQ or Kafka or Redis. Kay kinahanglan man ta yun naman to determine ang format no, to really uh, put up put in put a kuan no kanang parsing mechanism during the process of two applications communicating, no? And then there is a message broker in place, no, or in between them that have been placed. Okay, so when to use Java MQ? No, when the time comes to choose message processing API, no, Java Message Queue is a superior choice when compared to tightly coupled APIs such as REST and RPC in the following scenarios. So highly dependent kay siya sa ilahang mga API. Kaya atong sa RESTful service, no, kaya na magamit og simple HTTP mechanism, REST man na siya. For an RPC, when you share object, when you share a method alone, it's called REST. When you share on objects or RPC na ganyan siya. Ang i-remote nimo object na ganyan. RPC mechanism. So, want to use the no, JMQ. So, dapat kung gusto ka nga ang usa ka operation dili kay siya dependent, no, sa usa ka API. So it would be a much more superior choice compared to the REST and RPC. So this comes on the following scenarios, no, where a high degree of independence between the applications compared is needed. So the components should share nothing, such as the changes in design or permutation in one component have no impact on the other that collaborate with it. With it. So this eliminates the risk of cascading failures, no, when replacing or updating the components. When you want to eliminate the risk of a single point failure in the application, Application should continue functioning normally regardless of whether all its components are up and running. So where your business model requires an eventual consistency guarantee in the system such that system can still perform other activities as it continues to wait for input output to complete, where the applications need to communicate in many way, one to many, communicate in many to many, one to many, or many to one architecture. When you have background jobs or long-running processes that will require immediate feedback. So diha na nimo siya i-apply on JMQ. So that would be all for my discussions. So I hope you watch this video. So God bless. If you have questions, no, you can put it up on the forum below. So i-attach na ako ni ako ni siya i-upload sa LMS. Mag-expect mo forum below ani nga video. So have a nice day.